Again, Kevin Culp back at you from Super Micro, continuing our podcast on building the infrastructure for a neo cloud. In the previous video, we focused on really the layer 3 and layer 2 switch configurations, the leaf and spine configuration that's physically going to give us access out to the internet based on those instantiated VMs in containers, AI containers. So in this particular video clip, we're going to focus on the physical servers that are part of that Kubernetes compute that are associated with the control plane, the SDX control plane of that shard. We're going to be picking on the Geo West shard specifically, and there are three Kubernetes compute that are part of that control plane, SDX control plane of that shard, and that is Kubernetes 10, Kubernetes 11, and Kubernetes 12 compute, right? So compute 10, 11, and 12. You saw in the previous video where Kubernetes compute 10, we plumbed out the appropriate VLANs for 904 of that one as a tagged particular interface, right, for that physical NIC that's connected into its corresponding leaf switch. So we also have duplicate of compute 11, so its physical NIC that's connected to that physical switch port is also been plumbed out to tag VLAN 904, as well as compute 12, its physical NIC connection connected to a switch port of that leaf switch in rack 4 is also been tagged for VLAN 904. So that gives us the physical tagging out for those instantiated VMs to participate in its appropriate subnet. So we're now going to focus on the physical computes of the cluster. So the first thing that we need to understand is what role is basically each of those compute 10 and 11 and 12 participating in that Kubernetes compute. Is it a control plane or is it a worker? And the easy way to do that is to issue the command from each corresponding system. So we'll start with 10, and we're going to issue the kube control command get node. And we see here that the worker is basically from a control plane perspective, the Kubernetes compute is compute 10. So 11 and 12, because the roles are set to none, are workers. So you say, well, gee, Kevin, why do I need to know this information? Why is it significant to know this information? And it's very important here is in how I actually configure my bridges for each of those particular corresponding computes of that Kubernetes cluster and how I associate a VLAN tag for when I substantiate an AI container or actually a virtual machine, it's physically going to utilize that vport vNIC configuration of each virtual machine. Because when you basically instantiate those VMs, they could either be participating in Kubernetes Compute 10 and have that physical connection to be running and utilizing that as essentially a hypervisor as well as compute 12. So any one of those particular virtual machines could land into any of those physical servers to be able to utilize it as a workhorse, right? So it's very important that you understand this concept of how you're actually going to build that infrastructure to be able to support the services necessary when you instantiate these VNs and you're going to utilize those floating IPs. If you don't set that up correctly, none of those VMs will ever get out onto the internet. And then you're going to have a mess on your hand of trying to figure out where is that particular server landing as far as a virtual machine? Is it being hosted properly? Is the VLAN tagging set up correctly? And then you're going to have to walk it right back to the L3 switch. So it's really important to understand the relationships on your network topology of how these are all interconnected together. So working closely with your network engineer to understand how this is all plumbed out. Sometimes that can be very challenging and difficult because Your networking guy is basically in his own world, right? And he is focused on just being able to support the corporate network, right, or the enterprise network. And he's very much focused on VLANs and layer 3 switching and L routing, whether he's bringing in BGP route reflectors and all that kind of gobbledygook he's focused on. And he may have no clue how Kubernetes works on the virtual machine side or on the control plane or this new notion of this neo cloud. Like he may not understand those concepts, right? So if you're one of those type of people that you can step into the networking side and also the server side, you're like really a complete a really important asset to your enterprise to be able to do this. So it's very important here you understand the relationship here as it relates to the control plane and also the workers. So you probably say, well, first of all, why should I? So what is this relationship here? We're talking about control plane and workers. So I'm going to step back a minute and say this. If you're looking at this particular command, kube control get node, the first thing that you need to ask yourself is, do I see specifically scheduling is disabled? Do I see a node that contains both the control plane and says scheduling disabled? That clearly means it is a pure control plane and doesn't require you to be able to utilize your network plumbing as far as a bridge is concerned, because it's strictly a master that's going to service both of these particular workers, right? If you see where it says control plane here, that means it's a control plane and also, or what we refer to as a master plus a worker. So it's also going to participate in basically divvying up instantiation of containers and virtual machines. So all three of these technically will service your particular guest instances and containers, right? So in that particular use case, you need to make sure that each of these particular servers that are a part of this Kubernetes cluster are configured for a bridge and VLAN tagging, so that when that electrical connection makes between the vPort and the VNIC on each of these configurations for each of these hypervisors, you're going to be successful in being able to ping out into the internet. Very important thing to take a look at, right? If the node role is empty, this means it's basically a pure worker. So in each of these use cases, you want to make sure that there is a configuration here on the worker and also a control plane or master that you configured bridges and tagging, as well as these are two workers because they're showing up as basically none. So how do we see this configuration? How do we actually configure a bridge and be able to make that electrical connection between the vPort and the VNIC is very important. And so how we do this is we go into NetPlane, which is in the etc directory and NetPlane directory, and we take a look at each of these particular installer config YAML files that we utilize under the Ubuntu operating system. And so we're going to go to each one of those, and we're going to subsequently go into each of their directories and take a look at each of these installer configurations and see how they are actually configured. So we're going to catalog, cat out, so that's how we actually take a look at the contents of the file. And we're going to do this on both of these or those three nodes. And so you can actually type in the 0 and tab and it'll fill in the rest of the space for you there. And so we're going to do that on all three nodes. And you can see here by looking at our configuration, the NIC 1 or LAN 0 is how we're physically connecting out into the network of this particular physical server. And this is configured As you recall and remember, Compute 10 was configured as a native VLAN, so it's an untagged frame. And we see the default gateway here of 172.24.169.1. And this represents our management network connection into each of these particular physical servers. So if you need to make any management changes, I'm utilizing that subnet to be able to connect in through a PuTTY SSH connection for both Compute 10, Compute 11, and Compute 12, right? So I'm able to connect in here based on SSH because each one of these particular NICs that are physically plumbed out to my physical switch are configured in the native VLAN or PVID 671. All right, now I need to also pass to that particular connection now a fully .1Q trunk. So you remember here that NIC 0 was configured as a .1Q trunk because we basically had there the leaf switch configured for both native VLAN 671 and tagged interface 904, which represents the geo west shard where my communication is for my control plane. Very important concept to take in here. So VLAN is also configured as 904 for each of these particular physical servers that are going to be serviced in VLAN 904 so that those virtual machines will have a complete subnet of floating IPs to be instantiated for containers through PyTorch and TensorFlow, as well as our virtual machines. If you're virtualizing Windows or Linux flavors of hosts such as Ubuntu, Rocky Linux, and all CentOS and RHEL based servers or virtual machine hosts. And you can see here we've made the association of the NIC. We're giving it a 904 tag VLAN. We're utilizing false because we are not utilizing any DHCP. So both of those are basically set to false. In this case, if you were doing any IP subnetting through DHCP, we'd obviously configure it. But in this use case, we're not. We're going to let the control plane basically utilize those floating IPs. So it's not necessary to configure DHCP on the physical host. And then so you don't have to put these here. I just put them here for this use case so that you understand the significance of the floating IPs will be generated upstream at the extraction layer of the control plane through SDX, right? Super Developer Console. And then if we also come down here, we have our bridge one interface configured for each of these physical hosts. We associate it with a VLAN 904 tag. And here you go. You have your full plumbing of the physical servers to be utilized. So theoretically speaking, when those virtual machines get instantiated, and we'll show this a little bit later in this video podcast, it can ping out into the internet through a simple ping.8.8, and we'll show you that in this particular ability to do that in that use case a little bit later in this podcast. So a couple of things to note here is the relationships that exist between each of these workers and also masters. And remember, using the kube control get node command is going to be important here of whether you're going to configure these physical hosts for access out to and configure bridges. So that's the takeaway from this, understanding the relationship between masters and workers and being able to utilize the configuration through NetPlan to associate the plumbing for those virtual machines and containers to successfully get out to the internet and use their floating IPs. So that concludes this particular piece of really plumbing out the physical hosts that are participating in the Kubernetes cluster. Compute 10 is the master, 11 is the worker, and 12 is the worker. they are been deployed and imported into the control plane, the SDX control plane of our super developer console. And when we initiate those virtual machines through the GUI of the SDX control plane, such as through the GUI of Super Developer Console, you'll see here, once we instantiate containers through PyTorch or TensorFlow, our virtual machines, they'll be able to ping out into the internet. Thanks for joining today. Have a great day. We'll see you across the aisle.